Okay, this is Dave Reitzman again. I hope you've all decided to stick around for the first one. If I'm talking to an empty room here, then the first round must have gone pretty bad. So hopefully you all stuck around. Um, this is the second of two examples that we're going to talk about today for guaranteed energy savings projects and wastewater. I just got done talking about the city of Bloomington. And here's a little bit on the opposite extreme, the city of Winchester. So whereas Bloomington was 70,000, city of Winchester is about 5,000 people, whereas Bloomington had done, this was their third phase of projects, city of Winchester had never done a guaranteed energy savings project before. So the city of Winchester's in eastern central Indiana. 5,000 people, a much smaller facility, only about 2 million gallons per day. Again, they'd never had done or even really heard about performance contracting before. And the compelling event that caused them to even go down this path was blower failures. They were starting to kind of lose one blower, had another on its last leg, and if they, for any reason, lost their third blower, they weren't going to be able to keep that plant up and operating, which is a very serious situation for them, and they needed to do something in a very short period of time. So we approached them with the concept. The RFP was put out in March of 2005. Construction started in July of 2005 and was completed about 6 months later in January of 2006. The facility there, similar to City of Bloomington in many respects. It's a conventional activated sludge facility with aerobic digesters. In this case, all of the work was confined to the aeration basins and the blower systems. The initial meetings happened back in September of 2004. We completed a feasibility for them that looked at a wide number of issues with the plant. It was probably 18 years, 19 years since it had been constructed, and they haven't had any major renovation since then. So they had a lot of equipment approaching the end of their useful life and really needed to do something. So the aeration system was decided as their top and highest priority that they had to address. So they put out a request for proposals. I apologize, it says one response. They actually got two responses back for them, and they selected ESG to move forward with the final project. The contract was authorized in June. So it took about 5 months from the RFP response to get through the negotiations, get through the financials and legal paperwork, to get through all of the Board of Works and really everybody in the city that had to have a part of this, all the stakeholders, to get them comfortable with what was going to be done, what was going to be the scope of work, and really the back end financial guarantees. That was something we spent a lot of time on because they had not gone through this before, how it worked, what was guaranteed, what was not, and how that was going to affect them. So the project team was similar in many respects. Some of the same people we used at Bloomington, we used from a contracting standpoint up at Winchester. We had a different design engineer, and in this particular case we had them work directly for us, do the design, which we then gave to the wastewater general contractor to install. Similar responsibilities. They were involved with making sure that the process was met, there was no impact on permit, reviewing submittal drawings, and being involved during the construction phase. So if there's any issues that come up, they were going to be there as well. This particular design engineer also had a role as the city engineer. So they were wearing a couple hats. They were working on this project to make sure it was in line with all the other things that were going on. And at the same time, they were occasionally representing the city to make sure everybody's best interest was at hand. And they did a great job, and it was very well, and it gave at the end of the day, the customer a great peace of mind that they knew that their trusted advisor was going to be involved in this particular project to watch out for them. Again, similar focus here as the city of Bloomington. They had coarse bubble diffusers, and we took those out and put in ceramic disc fine bubble diffusers. From an aeration piping scope, they were in probably much worse shape than Bloomington. I think their patches had patches on them from an air loss standpoint, and so it was all replaced from the blowers all the way down to the submerged diffusers. And a lot of air savings, I think, came as much from fixing air leaks as we did from reducing the demand at the diffuser level. They had 150 horsepower centrifugal blowers, single stage originally, and we put in variable speed positive displacement units. Centrifugal blowers, it's difficult to put variable speed on. If you turn them down too much, you'll get into surge conditions, which can ruin and destroy a blower. So the nice thing about positive displacement is they easily accommodate variable flow capability. And in this case, since we were putting in dissolved oxygen control, which I'll talk about more in a minute, we wanted the ability to easily ramp up, speed up, and slow down these things. And it came with a nice package with the VFD integrated into them. So during low load conditions, they could really dial the air back and maximize their amount of energy savings for this facility. So we started with 150 horsepower centrifugals, and we went back in with 75 horsepower. So this is a vivid example that the fine bubble diffusers drop your air consumption in half or more just at the demand side. So I think we talked about chronologically, Bloomington was first for the projects we were involved in, and we wanted to put in DO control, but we did not. Winchester came after, and we did involve it. I think at early in the development of the dissolved oxygen sensors, there was some maintenance issues with the sensors, and they had to be replaced relatively often. The technology is continuing to improve. The floating heads that we put on here probably needed replacement once a year, and they even have much better technology available today to continuously monitor dissolved oxygen control, get that signal back to the blowers, so we can maintain that nice 1 to 2 parts per million that you want to keep in your aeration basins. The pre-project levels were 5 to 8 ppm. Which is not unusual in most plants. They were running one shift a day, so they would adjust it such that they were meeting their need, and then walk away at night. And so you always want to make sure that they have a nice residual level. But the consequence of that is they were constantly over aerating, oversupplying blowers, which has a very large energy impact back on the system. And so having continuous monitoring and control, even when they're not there, provided that last bit of fine control to really reduce their energy at this plant to its lowest possible level. The overall project was around $800,000 with 10 years at 4.4% financing for a 7-year simple payback. What's really impressive, I think, in this graph in the lower right-hand corner, you'll see, is that while the guaranteed savings were $560,000, they actually have garnered over $635,000. So there's quite a bit of additional savings, and it's not really anything that we did with the technology or setup. It really goes back to the owner, because they saw more savings than what they had predicted. It gave them additional revenue to go and attack other things in their system. And they did some sewer lining on some near riverbanks that had a lot of I&I, which further reduced flow, which further reduced their energy back at the plant. So sometimes we talk about these projects as a way to move from a reactive state, constantly dealing with emergency breakdown, getting a little bit ahead in the deferred maintenance cycle, and switch into a proactive state. And this city really did a great job of taking the reins, capitalizing on this project to a great degree and continue to aggressively go after inefficiencies out in their system. But it's always a question of money and funding. And so this excess savings allowed them the capability to go attack some of these other things and weaknesses in their system. So it's a nice story, and kudos to them. So why did they go down the path of a guaranteed performance contract? I think, well, certainly they had to do something. You know, they had failing blowers. The Department of Environmental Management from Indiana was going to be on them if they didn't do something in a quick period of time. So, but they certainly could have gone down a conventional design bid build approach. So when we were dealing with the mayor, what caused him to want to go down this path that they had never done before? And I think it was a couple things. One is it was guaranteed performance. The idea that they were going to get a guaranteed maximum price, the fact that we were bringing financing to the table, and that we were going to work with their incumbent engineering firm gave him the peace of mind that this was a great business practice to engage in. This particular mayor had come from an industrial background where kind of design, build, delivery was the accepted method for how you do projects. And so bringing this best practice from the private world into the public world was something he was familiar and comfortable with, and just was looking for somebody to explain how to meet all the legislative and procurement guidelines to meet the state requirements. So, and finally, because they could do this improvement without raising rates, I think was what sealed the deal. To pay for it with savings was hugely attractive to the city and to the Board of Works, and get this needed project done. So was there any due difference in this particular case? I think that if anything, we addressed the most critical and urgent need, but there was a wide number of other projects that could have been addressed that was held off. I think they held off partly because, again, caution. They had never done this before, wasn't sure how far to go, and I think there was enough savings and room in the budget to attack some of these other things around at their plant, but they didn't. So there's a phase 2 actually in development. They're looking at going back and catching up on some of these other deferred maintenance items to see if they could be included in a project. So what I like to tell people, because the situation comes up frequently in the development, is, you know, where do you stop? How much can we afford to do? There's almost always more need than there is money. So what we try and do is bundle quick payback items with long payback items and address the biggest number of items that you can, because there's a huge investment in staff resources and time to get this project moving through. You only have so many hours in a day to put your mind in any one thing, and when you're trying to run a city, the wastewater treatment plant is only one of many items that you're working on. So if you've spent the time and energy to develop this project and populate it with a number of things, maximize the number of items you can get done. It's in everybody's best interest to do so. You get lower cost of including it then rather than putting it off till later. Always you're trying to balance needs with fiscal requirements, so that's always the balancing act you have to do. But certainly we recommend that if you can get these other things done and get them bundled, it's in both the technical benefit from capturing energy savings, but also from a cost standpoint, it's lower cost as well. So we've talked about two different projects here, large and small, both wastewater, of how people have addressed some needed infrastructure. Bloomington could certainly have continued to have done nothing, but over $100,000 a year of savings would have been lost, and they wouldn't have those needed improvements back to their system. The city of Winchester had a compelling event, so the blowers. They had to address them, and they found a budget neutral way of addressing those. In a lot of other situations that we deal with, maybe the aeration system has already been done, and so one of the big energy savings is not available to you. So where else do you find potential savings? There's always pumps, motors, control systems. We're continually finding a significant amount of savings from better operational control of things, and just getting somebody else to come in and look at it from an external standpoint. In whatever case, these are two great examples of cities nearby that have done this, have had great experiences doing with it, of performance contracting. It got done on time, on budget, and in one case they're looking at come back and doing it again. So we hope that when you do your performance contract, you'll have a similar positive experience. Thank you very much today for allowing me to present. Apologize again for not being able to be there in person. I hope this method of delivery wasn't too uncomfortable for anybody. And with that, I'm going to let any questions that need to be asked, and maybe you guys can have some dialogue and talk more amongst yourselves. Thank you much, and have a great day.